Yeah. Okay. Yeah. Yeah. I'm very happy that finally we have this WINLAB research review coming back, and usually we have it twice a year or once a year. But for the pandemic situation, this has been delayed. But it is really great that we see that things are coming back, and gradually we can. Putting things more in the regular fashion, and then we can continue to do our research, and all the students and the faculties have started going back to the lab, and all of our research work can go back to the normal situation. So with being that said, I think WINLAB will still keeping very busy in doing research, even under the pandemic situation with the faculties and the students. And today I'd like to talk about our new testbed, which is synergetic with the existing Cosmos and also the new Cosmic testbed. That what we're doing is that we are going to the edge side of the devices. We started with the core networks, and now we'll all reach out, okay, to the edge sensing and computing. So this testbed we're looking at is the community-based mobile edge sensing and computing testbed. And in WINLAB, Ray, Yvonne, and myself, and we're working on this testbed. And this testbed will also be connected with the Cosmos testbed eventually. So if we take a look at the mobile edge sensing and computing community, we see that currently there are many interesting research work and also applications rely on the edge sensing. Okay, there are many sensing capabilities that people, researchers are working on, that we're using acoustic signals, vibration signals, visible light, and also Wi-Fi signals. And a part of it now also expand to the millimeter wave. So there's a rich sensing capability out there, okay, in the edge. And by looking at that, it also enables many applications. Okay, I listed a few of them. It includes, for the indoor environments, we can look at the gesture recognition to enable many smart home capabilities, and well-being monitoring to help the healthcare domain, mobile healthcare domain. And then we can also look at the human dynamics. For example, we measure the human dynamics in a smart building environment, and even we look into the traffic monitoring in the smart intersection. So there are many things we can do by using the sensing. And of course, they can also help us to enhance the user security, where we see to help us to protect the user privacy and enable new authentication methodologies. So by looking at that, the problem we face is that currently we have many research groups are doing this work, but we're all focused on our own environment, because one major problem we face is that we find the experiments we performed in one environment cannot be transformed or cannot be transferred into another environment. And also, in order to achieve some of these applications, we have to do training. And the training is very labor intensive and time consuming. So by looking at this, right, we realize that different research groups, currently we conduct small scale experiments, okay, and we only share the results, okay, at the conferences by reading the research papers. Okay, so this is not sufficient. Okay. In order to have this mobile edge sensing and mobile computing environment be available to everybody and make all these applications really deployable in a large scale environment, we need to find a way that we can share these results, not just on the paper, okay, but we should be able to have an environment that provides repeatable experiments and sharing the research models, the data models that we conduct this research and derive those models. So this leads to the our project goal for this testbed. Okay, we would like to build this community-based, configurable, and a reprogrammable mobile edge sensing and computing infrastructure, so that it can be shared, okay, in the nationwide among the research groups. And especially, okay, we were going to talk about, we're going to support this on-device AI learning technologies, and also how to provide environment invariant modeling methods, so that those data models derived on this testbed could be shared among different research groups. So this infrastructure, okay, we are going to provide a web portal, okay, that can allow users in our community, they can access this infrastructure by scheduling their time, and also set up the parameters in the experiments. And we're also going to have the capability to support these various sensing capabilities. Okay, this includes the heterogeneous mobile devices that I'm going to talk about. So if I take a closer look, okay, of our infrastructure. Okay, for this infrastructure, what we have is that we have three main components. Okay, that we have it organically connected by utilizing a remote graphical user interface access. So we have the heterogeneous edge sensing functionality, okay, that we're going to provide the remote accessible smart cars and robots that will carry, okay, mobile small sensors or mobile devices, okay, to facilitate the experiments. And the second component is the mobile edge computing modeling part. So for this part, we're going to provide a simulation environment so that people can, based on the data they collected, okay, they can perform simulation to do the deep learning study. And further, we're also going to talk about our hardware and software co-design model. That platform will provide the capability for users to test the simulated model to deploy them on the resource-constrained mobile devices. And we call it on-device AI. And the third component is going to lies into the smart sharing. In that part, okay, it's the higher level. We're more looking into how to share the models among different users and among different environments, and even across different applications. So this infrastructure deployment, so what we look at is that currently, okay, we are collaborating, okay, with Temple University, Indiana University, Purdue University at Indianapolis, and also New York Institute of Technology. So for these four universities, okay, we're going to have different functionalities distribute in these four universities, and based on the activities at each university. Okay, like for Rutgers, okay, we are strong, okay, in building the test beds, and also we have this Orbit testbed and Cosmos testbed as our backbone. So we definitely, okay, we're going to more focus on the heterogeneous edge sensing part, okay, and also the mobile computing side, mobile edge computing side. Okay. While for the other sites, okay, based on their capability and also the students, some of the universities, they have more undergrad students. And for that part, okay, we're also going to look at how to carry this into the teaching side to involve undergrad students to collect sensing data and also to help them to equip with the deep learning technologies. So we have these four universities, okay, we will work together to develop this community-based testbed. So let's take a closer look of the heterogeneous edge sensing functionality that we have in this testbed. So what we face is that when we conduct edge sensing, okay, we find that, okay, the research groups, we have to calibrate the data constantly. And also we need to reconduct experiments. So there are many environment-specific information, okay, that change, okay, and vary every time, okay, from day to day, and even from hours to hours, depending on the type, the modality of the sensing modalities that we use. So what we like to do is that we're going to utilize the smart cars and robots, okay, to help us to carry sensors, for example, cameras, microphones, and help us to set up speakers and also motion sensors. And by using that, we want to set up an environment, okay, we want to set up an environment that can provide low effort data collection. And these days, we see that many experiments, okay, the setup takes the time, and also the training is very labor intensive. Many students and researchers, they spend numerous time in order to collect data that is for the training purpose. So what we like to see is that if it's possible, okay, for us to set up this various experimental environments, and then, okay, we can let the users to remotely control the smart cars and robots to tune the parameters in experimental environments. So for example, okay, we can let the robot to play out the sound, okay, for the acoustic sensing environment, and also for some of the experiments that we try to launch certain attacks, for example, acoustic-based attacks. We can also let smart cars to carry speakers and move into different side of the room, okay, to mimic the attackers to launch the acoustic attacks, including like hidden voice attacks and inaudible sound attacks. So by doing that, okay, we like to reduce the data collection efforts, and also the eventually, okay, reduce the data calibration efforts. So what we have is that we will see this, we call this as the environment customization, automatic environment customization that will be enabled by our testbed. And we also want to show that once we have this long-term data collection, one is that we're going to have large amount of data that I'm going to talk about in the next component. But in the meantime, when we collect all this data, some of this data related to the human voice and also related to the well-being monitoring. So those are the sensitive data. Okay, people usually have the privacy concerns. So what we like to do is that we show that we're going to build a federated learning-based mobile edge sensing methodology that will help us, okay, to perform on-device privacy-preserved data collection. So this is something new that we like to try, and we haven't seen it's being implemented in anywhere yet. But this is something very challenging. But we like to see that whether we can provide it to the community by using the federated learning-based edge sensing. Okay, and further along, okay, we take a look is that once you have large amount of data, okay, how can we perform? Okay, how can we perform efficient data analysis and also learning? Okay, so what we like to do is that we would like to show that many deep learning methods, okay, deep learning methods, they require this intensive computations, okay, and also demand high resources. A lot of times, the data needs to be uploaded into the cloud to perform the deep learning model analysis. So what we'd like to do is that we like to see that whether it is possible, we can create this repeatable and shareable environments that we provide the hardware and software co-design methodology to let the users, once they collect the data, they can work on the remotely work on the FPGA platform that we're going to develop. Okay, that can let the user to try to deploy the deep learning methods, okay, all the models that through the pruning and compression, and try to utilize those models into the local edge devices. Okay, so first we can try it on the FPGA devices, and also we will provide the functionality. Okay, we'll provide the functionality with a series of pruning methods and also compression methods that we'll see that whether we can perform this real-time data processing and deep learning inference on the resource constraint mobile devices. So eventually, we like to see that we like to reach the goal is that we can do this deep learning model dimension reduction, okay, and then to run the complex models, okay, in many mobile edge devices. And moving along, for the third functionality we like to provide is we call the smart sharing. Smart sharing, actually, we view it as very important because these days the research groups, okay, we just develop our own methodologies, and the models cannot be shared, and this actually increase a lot of efforts. Okay, one is in the research side. When we try to move the research forward, a lot of times we say that we need to stand on the giant's shoulder. Okay, so if we can reuse other research groups data and utilize their deep learning methodology, and eventually if we can conduct experiments in one environment and then they can apply this results in the other environment, in their own environment, okay, that can reduce many redundant research efforts. Okay, but to let people focus more on the fundamental research advancement. So for this smart sharing, okay, what we like to do is that we like to provide this environment invariant modeling. That is, we want to see that how we can collect data in one environment, but it can be deployed in a second environment. And also, okay, for those sensitive data, once they are stored, okay, we also like to provide the privacy preserved data sharing capability. And finally, okay, when you have different applications, okay, for example, okay, in the smart home environment, we have this gesture recognition method, okay, that to operate appliances, in the smart home environment. But on the other side, we can also have a different application, okay, that is by looking at people's gait patterns, okay, to do the health monitoring. Okay, so this we call the cross-objective applications. Okay, that even in this, okay, when we look into the deep learning models, sometimes we see that features can be reusable, okay, across different projects, different applications. So eventually, okay, on top of the environment invariant modeling, okay, we also like to see that whether it is possible, we can extract transferable features, okay, with the pre-trained models, okay, that can be utilized in new applications. So by doing this, okay, we need to identify similarities across the research objectives and also the experimental setups. But if we can identify those transferable features, okay, definitely this can shorten many redundant research efforts across different individual research groups and can help, okay, to let people focus on the fundamental model development and the fundamental research items that for each specific application. So just to summarize, okay, we are going to provide many new research tools and also data sets. So just to name a few of the research tools, okay, we're going to have this platform monitoring and environment management tool. We also have this edge node configuration tool. These are all helping us, okay, to adjust experimental environments and also configure sensors. And further along, we also have this on-device AI benchmarking tool. This will help us to develop a set of benchmarking suite when the people are testing the hardware and software co-design architecture, okay, by using this mobile edge devices and also the sensing collected sensing data. Yeah, we're also going to provide interface to let the users can configure and reprogram the edge computing devices so that they can measure the resource constraint and also measure how to utilize the resource efficiently, okay, in the hardware software co-design environment. And as we also talked about, we're going to provide many new data sets along this side, including both sensing data and also the deep learning models, and eventually the environment invariant models. Those are also part of the data sets that we're going to provide to the community. Okay, so that concludes my talk, and I'd be happy to take questions.